All right, so solving the radical equations, we've got the warm-up for the absolute value from last class. I'm going to go ahead and move forward from there.
Thank you.
Once again, we already talked about this, but the important thing to note that may be unfamiliar is that if you have the square root of a number, the square root of a variable, it has to equal a positive number, not a negative. If you end up with a negative, you have no solution. So that's an important part of what you're checking on as you go through these problems. So 3 equations that will not have a real solution are essentially anything that has a squared variable to equaling a negative number, or the square root of something equaling a negative number. So square root of x equals -4 will not have a solution. X squared equals -13 will not have a solution. And the square root of x minus 4 equals -1 will also not have a solution. Anything that will have one solution is the square root of something equaling a positive number. That's just going to be a single number. On square root of x minus 4, we would add 4 to both sides. So this would be the square root of x equals 5. So positive number, that's going to be a single solution. Same thing with the square root of x minus 4 equals -1. Positive 1. That's going to have a single solution. What we have with these last two are going to be both 2 solutions, because when we square root to solve, we have both a positive and negative. So as confusing as that may be, do keep that in mind. So we know that it will not have a solution if it is an x squared equaling a negative. I'll write out negative. Or if it is the square root of x equaling a negative. If we have the square root of x equaling a positive, it will have a single solution. And if we have x squared equals a positive, it will have 2 solutions. So when we actually solve these, we need to use the inverse operations to get our square root alone. And then once we have that alone, we're going to square both sides to solve. So we are going to add 4 to both sides here, have the square root of x equal a positive 3. Square both sides to get x equals 9. On part B, we're going to divide both sides by 2. So we have the square root of x equals 3. Square both sides. So x equals 9. On part C, remember when you're solving multiple steps here and you're trying to get rid of multiple things, you're basically doing the order of operations backwards. So when you have parentheses, exponents, multiplication and division, addition and subtraction, as you're trying to get rid of these parts, you're going to go backwards. So you're going to undo any addition and subtraction first. So you've got 3 times the square root of x equals 18. Then you're going to undo multiplication. So you have the square root of x equals 6. And then you're going to undo, that's essentially an exponent. So we have x equals 36. On the last one, get rid of the 1. So we'll subtract 1 from both sides. 2 times the square root of x minus 2 equals 10. Divide both sides by 2. Make sure you understand that that 2 only affects the 2 out in front. It doesn't affect what's happening underneath that square root sign. So we've got the square root of x minus 2 equals 5. Once we have the square root part alone equaling something else, then we square both sides. And we're left with x minus 2 equals 25. So we got one further step. So x equals 27. So the way that I would summarize these steps would be to use inverse operations to get the square root group alone, or to isolate the square root group. Square root, also known as the radical. And then the second part to that is to make sure it equals something positive. If there's a variable on the other side after you isolate the square root, then you don't have to worry as much about the positive, because the variable can change that. And we'll look at that in another example. So that's all in step 1. Step 2, square both sides and solve for x. Depending on what it looks like once you square both sides, the solving for x be a fairly lengthy procedure. I'll show you that in just a moment. So here we have an example of x's on both sides. We still need to worry about that square root first. So on the left side, we have the square root isolated. So we can jump to that step of squaring both sides. Where that gets tricky is making sure that we treat that like it has parentheses around it. So when we square both sides, the square root and the square on the left side take care of each other, so we're just left with the x minus 4. Over here, though, on the right side, you need to make sure you remember that this is not x squared plus 36. This is x minus 6 times x minus 6, which, if you multiply it all out, is x squared minus 6x minus 6x plus 36. So x squared minus 12x plus 36. So make sure you remember that. So that all equals x squared minus 12x plus 36. I'm going to make a little squiggle between there. So in order to solve this type of problem, you have to get everything over to one side equaling 0. So I'm going to subtract x from both sides. I'm going to add the 4 to both sides. Bless you.
Thank you.
And so I've got 0 equals x squared minus 13x plus 40. At this step, you have a couple of options for solving. Your two most obvious options are the quadratic formula and or factoring to use zero product property to solve. Any preference on which one I use? Okay. I'm going to go ahead and factor to solve it, but I'm going to pause the video because that's a lengthy process. So once we're down to that factored form, equaling 0, set each part equal to 0. So x minus 8 equals 0. X minus 5 equals 0. So x equals 8 and x equals 5. So those are our two options for, or those are our two answers for x in this equation. However, we need to check that for an extraneous solution. So what we're going to do is simply plug each of those back into the original equation for both x's and check and see if they both work. So I'm going to do the 8 first. So this is my check over here. Actually, I'm going to put that in a different color. So square root of x minus 4, so I'm going to put 8 minus 4 equals 8 minus 6. 8 minus 4 is 4. 8 minus 6 is 2. Square root of 4 is, in fact, 2. So we're good to go on 8. So 8 is a valid solution. On the 5, we're going to do the same thing. Square root of 5 minus 4 equals 5 minus 6. Square root of 5 minus 4 is 1, or square root of 1, and then that equals 1. 5 minus 6 is negative 1. So we end up where 1 equals negative 1, which is not true. So that one is our extraneous solution. And we'll take a look at the graph in just a minute and see why that is. All right, so using the graph to check, we're going to take both parts of our equation and we're going to split it. So we're going to take the square root of x minus 4 and make one equation out of it. And the other one, we're going to take just the line x minus 6. We're going to graph both of those on the same grid. So the square root of x minus 4, if you guys remember, that square root was basically a sideways parabola, something like that, but just half of it. So the minus 4 underneath the square root makes that our h value. So it makes h a positive 4. And since there is no plus something or minus something outside of it, then it's just 0 for our k value. So our hk is 4, 0. So we're going to start that at 4, 0. Up 1 and over 1, up 1 and over 3, and then this would be up 1 and over 5 if we were to continue out. And then our line, x minus 6, is going to have a y-intercept of negative 6, and it's going to have a slope of 1. So we're going to go up 1 and over 1 and continue. Whoops, that would confuse things. So that line is going to go through here, and the point where they're going to cross, and you can actually see them cross on the graph, is where x equals 8, which was our valid solution from above. Now, if you look at the graph, which is not, if you look at it as not a function, I'm going to take off that 8 part. There we go. If we look at our little sideways parabola and we fill in what would be the other half of that, which makes it not a function, so we're not going to do that, you could see that right here where those cross is where x equals 5, and that was our extraneous solution. So that's where that idea of that extraneous solution comes from, because of the nature of a square root. Actually, so get rid of that part. Oops. Oh, for heaven's sake. I went too far. Okay. So, where you can actually see them cross is where you're looking at your actual valid solutions. So on this last part, to demonstrate why these have two solutions, we're looking at each of these as separate equations. So we have our x squared as a y equals x squared, and our 9 as y equals 9. So y equals x squared is just your basic parabola. out 1 and up 1 and out 1 and up 3 and out 1 and up 5. And then y equals 9 is just a flat horizontal line at y equals 9. And so what we note here is that we have two actual places where they cross, and both of these are still functions. So we have two solutions for a problem like x squared equals 9, which we have x equals positive 3 and x equals negative 3. Square root of x equals 3. If we look at those again as two different equations, the square root of x is that half a sideways parabola again. And then y equals 3 is going to be a flat line where y equals 3. And once again, they're crossing, bless you, at only a single real place. So x equals, shouldn't equal that. I'm in the wrong place. This is why graphing is difficult. Solving by graphing, they're actually crossing there. So x equals 9. And then our very last one, if we look at that square root again, and graph that, and then we graph negative 3, we don't have any point of solution or point of intersection. So that is the investigation. Make sure that you have the practice worksheet for this as well. And let me know if you have any questions on that.